All right, so let's talk 2.2 number 5, first things first. All right, so we're supposed to choose a right-hand side which gives no solution and another right-hand side which gives infinitely many solutions. So the first thing I'm going to look at this system, and they said this system's singular. How can they tell that this system is singular? Like, what are they looking at to ascertain that? What does it mean for a system to be singular? Okay, so let me go look. Let's see, where did we talk about that? Interpreting a matrix equation? Matrix is a function. Uh-oh. Idea of elimination. Uh-oh, this is what I'm going to get for splitting these into little pieces. Oh, God. Oh, God. I don't see it anywhere. Shit. Maybe it's here. Oh, no. Uh-oh. All right. Oh, it's right here, isn't it? No, it's not. Is it here? Do we have we talked about this? Oh, shit. Okay, so let's talk about it now then. I'm pretty confident we talked about this, but I can't find it, so I have no proof of that. So a singular system is one where the rows or columns are linearly dependent. Now, this is a little overkill because if the rows are linearly dependent, then so are the columns. If the columns are linearly dependent, then so are the rows. So I really have made a little bit of overkill here in saying that the rows or the columns are linearly dependent because one implies the other. But whatever. Okay, so in this case, what is the kind of obvious path to get from here to there?
2.
Yeah, I'm thinking multiply by 2 will get me from row 1 to row 2, right? Okay, so I need to fill in a number here so that I get either no solution or infinitely many solutions. You guys with me on that? Right now, what I'm thinking is that this top thing, if I think about that in the kind of row multiplication picture, that thing is a line, right? You guys see that? This other thing is a line with the same slope. You guys see that? So here's a line. This is the line 3x plus 2y equals 10. If I want to have no solutions, right, where do I want to go put the line 6x plus 4y equals something?
Not touching it, so parallel.
Yeah, it needs to be parallel. Now, the fact that it's 6x plus 4y is already giving me that it's parallel, but I want it to be parallel and what? Okay, here we're gonna see some. Go ahead, Jordan. Sorry.
I was gonna say on like a different plane or like shifted to a different y intercept.
Yeah, like this would be infinitely many solutions, right? If they're sitting on top of each other, and this is not. So I need them to sit somewhere else. So I need this to be a different equation than 3x plus 2y equals 10. So how do I make this a different equation?
Well, I'd probably do it in a boring way and turn it into y equals mx plus b.
Okay, you can do that. This is a lot easier than that. All we need to do is make it different. And if multiply by 2 is what takes me from black to blue, I just need to make sure that 10 doesn't get multiplied by 2. You can multiply by anything else you want. I'm going to multiply it by 1. You guys see that? Now these are two distinctly different lines. Hence, there's no solution because they're parallel and different. You guys see that? Now, if I want to make that same picture but with infinitely many solutions, let's see, I just need to pick these two guys up. Oops, that was the wrong button. Cutting them's not going to help me at all. All right, and I need to dump this 10 here. And then I want to pick this guy up and make sure it sits directly on top. So what do I put on the right-hand side there?
20.
20. Oops. You guys all with me on that? So if I was writing this problem on my homework, right, I'd write some little explanation off in the margin like, a system is singular when one of the rows is a multiple of the other. It has infinitely many solutions when they contain the same information, i.e. when the blank is filled with 20. Maybe even draw this picture. You guys see that? Do note that the rows or columns here I'm talking about are the rows or columns of this side. I'm thinking about that as a matrix A times a vector X, right? And I'm talking about the rows or columns of that matrix A. Does that make sense? Okay, so let's fiddle around with number 6 just because we're right here, and I think it's a pretty approachable example for this. So I'm supposed to choose a coefficient b to make this system singular. All right. How do I do that? What am I looking at in order to get that to happen?
You could make B4.
Good. I could and should make B4. Oops, and my writing tablet turned off. Like I said, I could and I should make B4. Get my tablet back on. Sad face technology. Finicky USB. Okay, so now that I've made B4 to get a singular system, what is my next goal? What are they asking for?
Choose a G that makes it solvable is what they're asking, but I don't really know how to go about doing that.
Okay, rad. All right, so let's think about why did Grayson pick B as 4?
Because it is 8y divided by 2, which is, I guess, their product center, or yeah.
Yeah, he's thinking, all right, so to get from this to that, I had to multiply by a half. So to get from 8 to something, if I want it to be singular, it has to be a multiple. So it's got to be the same multiply by a half. So now I'm rocking this singular system, right? So I've got my singular system, and it is 2, 4, 4, 8. Right? So that's my singular matrix. I'm multiplying this by a vector x times y. And I'm saying this is going to equal 16 and something. Okay, now in the previous example, right, I thought about there are infinitely many solutions when the whole row, right, including the right-hand side, is a constant multiple. And there's no solutions when the right-hand side isn't the same multiple as the left-hand side. You guys all on board with that? Okay, so now if I want to have some solution, I know that in this case, because it's singular, I can't have just one. I'm gonna have to have infinitely many. Does that make sense? In the singular case, you only get two options. You either get 0 solutions or you get infinitely many solutions. One is not an option here. Go ahead, Joe. Do you have a thing? Okay. All right. So if I was multiplying by a half to get from row 2 to row 1, what goes right here in order to have these have infinitely many solutions?
32.
Good. You guys all with me on that? Now, what is some solution? This isn't asked in the... Oh, no, it is asked in the problem. I need to find two solutions in that singular case. So I need what is a solution? How do I find a solution? This gets a little weird, right? Because this really boils down to there's really only one equation here. I made it so that the only one equation here is this one. You guys see that? The other equation is the exact same thing multiplied by 2. So it doesn't contain any new information. So I would claim that now you have a free variable. You guys see that? Which variable's free? I don't know. There's two. Traditionally, books will point at this one and say that this one's free. But I'm kind of lazy. I'll probably take that to be what? If I just need some answer to this, right? I just need some point on the line 2x plus 4y is 16. How do you find a point on this line?
I know the point. I just don't know how.
Okay, tell me a point. Sorry, say that again. I didn't catch it.
Put 0 in for one of them.
Yeah, sure. You can just, you've got two variables. There's one equation. You can just put 0 in for one of them. If you put y as 0 in, what do you get?
X equals 8.
Yeah, you get x is 8 right off the bat. All right, Jordan, what was one of your points?
2 and 4 and 4 and 2.
2 and 4 and 4 and 2. Let's see. So if I put x is 2 and y is 4 in here, I think I get 20, don't I? Must be 2 times 2 plus 4 times 4.
Oh yeah, not 2 and 4. 4
Yeah.
2.
4, 2, so that'd be 2 times 4 plus 4 times 2. Okay, that's 8 plus 8 is 16. Yep, check. Okay, so that one's on there. You're kind of eyeballing a solution, right? You're just playing like, oh, I know things about 2s and 4s. Here's a thing I can know about 2s and 4s. That's totally fine. That technique actually works. So here's a point. Here's a point. I obtained this one by kind of thinking, like, I looked at that and thought about, like, let's see, when y is 0, that's an x-intercept? Right? Whereas this one kind of came from a sort of a guess and check approach.
But really, you could just plug in a number for any of the variables, like one of them, and then solve for the other, and you can solve it that way, right?
Yep. Yeah, so like, okay, so 2 is a number. 4 doesn't go with it, but let's figure out what does. So if we plug 2 in for x, right? So if I'm like, hey, I really think I'm committed to having x be 2. So if x is 2, then when I plug it in, I get 4 plus 4y is 16. Let's see, so I subtract and then divide, I get y is 3. Okay, so the point 2 comma 3 is also on here. You guys see that? How many solutions am I going to be able to find? Good. The answer,
Approximately infinite.
well, yeah, I mean, the answer is 3 in this case because I answered the question, so I'm done. Right. But in general, yeah, you can plug whatever you want in for one of x or y and solve for the other one. So I think we could obtain a bunch if we wanted to. We could even find a formula, right? We'd like rearrange it with like a general, we could like, I don't know, like subtract 2x to the other side and then like divide by 4, and then we'd have like y as some kind of a relationship with x, and then we could just like throw x's at it randomly. If only there were a concept in math to describe that idea. We could probably even visualize it somehow if we thought about like x's going maybe from like left to right and y's from up to down or some crazy shit.
You're onto something here.
I mean, if only that were a thing we could do. Well, we'll have to dream. All right. Any other questions on these two? Okay. Your assignment is to flesh out that idea. Dream big. I bet we can do it.